Hello students, my name is David. Today I am going to show you Criminal Mathematics, concerning on Unit 2. You can refer the Unit 1 lessons from previous videos. For today we are going to see starting from Unit 2, which is concerning about solution of equations. Before we are going to see each topic of the Unit 2, let me talk about what are the components of Unit 2. The first topic or the first section is about equations involving exponents and radicals. The second topic is, or the second section talks about system of linear equations in two variables with their solutions, with different technique of solutions. The third type is equations involving absolute values. Okay, equations involving absolute values. And the last one is, which is a new and very important for you, which is quadratic equations. For today, we are going to see equations involving exponents and radicals. First, let me define what is an equation means. Equation is a system of combination of two expressions that connected by ways equal sign. Okay, equal sign. And when you say these equations, there is equal sign between two expressions. Okay, and you have to refer from grade 7, Unit 2 mathematics textbooks. In solution of equations, equation and equation may have a solution, or may have no solution at all. When you say equation may have or equation have solutions, that solution may be a single solution, one solution, or the other solution may be what? Infinite solutions. Maybe an equation may have infinite number of solutions. We will see in solution of or system of linear equations in two variables. So today we are going to see equations involving exponents and radicals. In this case, we are going to solve equations having exponents and what? Radicals. For example, solve here. It says what? Solve A, radical x is equal to 3. B, x cubed is equal to -8. C, x to the power of x is equal to 64. D, 4 to the power of x over 2 is equal to 64. In this case, we have to remember that exponents may be what? Radical, exponents may be rational, integer, or we can say that real numbers. Okay, we will see in next lecture. So let's start from A. A says what? The square root of x is equal to 3. In this case, we have to use different techniques to solve such kind of problems. That is, square root of x is equal to 3. This means you can say that you can square both sides. Okay, we can square both sides. And don't forget that the rule of transformations, rules for solving equations, we have learned previously. The square root of x the whole square is equal to 3, and square can be simplified just like this. X is equal to set square is 9. Whatever when you substitute the value of x by 9, you will get what? The number 3. This is the solution. Okay, this is the solution. B says what? X cubed is equal to -8. You can use the cube root of both cases, or you consider the cube root of the numbers. This is negative. The cube root of the numbers, or we can say that x to the power of 3 can be equal to -2 the whole to the power of 3. And you have to remember that the rule, if different bases having the same exponent must be, if they are equivalent, the bases must be what? Equal. We will see later. In this case, you can say that x is equal to -2, or we can say from this, the cube root of x is x, and the cube root of -8 is -2. That's in both cases you can find out the solution of x. When you come to c to the power of x is equal to 64. Now the bases are different numbers, and you can say that to the power of x is equal to the power of, you can write 64 as to the power of 6, meaning multiply 2 how many times? 6 times 7, finally you will get the number 64. Since the bases are the same, and which means the exponents are the same, finally we will see if the bases are the same. Okay, this means means x will be equivalent with what? 6. This means x is equal to 6. If x is not equivalent to 6, these two expressions are not be equivalent. So the value of x is 6d. When you come to d, 4 the power of x over 2 is equal to again 64. We can write 64 as a base of what? 4. We can again. This means 4 the power of x over 2 is equal to 4 the power of 3. 4 the power of 3 means 64, right? So this means the base are now similar, the base are the same. So we can solve x over 2 is equal to 3. This means multiply both sides by what? 2. Yes? Multiply both sides by 2 because by the rule of transformation rules. So finally it becomes what? X is equal to again what? 6. If x is 6, you can check it. X 6 over 2 is 3 and 64 means for the power of 3. Now they are becomes what? Similar. Let me see very important rules. The first rules of solving radicals and exponents. See, exponents. The first rule says that the first rule, if you see for a is greater than 0, and a the power of x is equal to a the power of y. You see, if and only if, you see, and if means if and only if, you see, x is equal to y. If the value of x is equivalent with y and the base are the same, you see, and they are equivalent, then the x and y should be what? Equivalent. Unless if a the power of 3 is equal to a the power of 4, you see, they are completely different, which is out of the rule of mathematics. The second rule it talks about if where a and b are any real numbers other than 0, a the power of x is equal to b the power of x. See, don't forget that a and b should be greater than 0. A greater than 0 or other than 0. We can say that if a the power of x is equal to b the power of x, this means if and again if and only if a is equal to b. These two rules are very important. Okay, these two rules are very important for solving equations involving radicals and exponents. So let me use this kind of rules to solve different examples. For example, say examples. You will see brief examples about by using these rules. Simplify. Since this equation we have to solve. Okay, we have to solve it. Solve A. For example, for the power of 2x plus 1 is equal to 4 the power of x minus 3. B, we can say that a the power of x is equal to the power of 2x plus 1. C 9 the power of 2x minus 4, this is minus, is equal to 27 the power of 4x. Let me solve. Again, we will see there are very different examples concerning about this one. Let me start or let me solve the 3 of the first one. Okay, here solution. The solution for A. The rule says that if a the power of x equal to a the power of y, x and y must be what? Equivalent. So the bases are the same. See, a the power of for the power of 2x plus 1 is equal to for the power of x minus 3. This means the bases are the same. So this means since the bases are the same, we can equalize the exponents. That is 2x plus 1 is equal to x minus 3. In this case, we can solve for x. This means x minus x is equal to negative 3 minus 1. We can write this like this. What is x minus x? This is x is equal to negative 4. Since the value of x must be equal to negative 4, in order to make it for the power of x plus 1 is equivalent for the power of x minus 2. For example, let me substitute the value of x by negative 4. 2 times negative 4 is negative 8. Yes, negative 8 plus 1, negative 7, right? And negative 4 minus 3 is negative 7. Yes. So for the power of negative 7 is equal to for the power of negative 7. So they are equivalent. B, when you come to B, it says what? A the power of x is equal to the power of 2x plus 1. In this case, we have to make it what? the bases are the same, right? The bases are different, but it's possible to change 8 to what power as power form of the number with base 2. So you can write 2 8 means to the power of 3, or the power of x is equal to the power of x plus 1. And by the rule of multiplication or by the rule of power, this means to the power of 3x. This means, you see, to the power of 3x is equal to the power of x plus 1. And now we make it the base are similar. Therefore, we can say that since the base are the same, we can equalize the exponents. That is, x is equal to 2x plus 1. Now bring this one, 3x minus, see, 2x is equal to 1. Because bring it x to the left side, it becomes minus. 3x minus x is equal to 1. So the value of x is 1. In order to make it 8, the power of x is equal to the power of x plus 1. You can check it by yourself. C 9 the power of 2x minus 4 is equal to 27 the power of 4x. Now we can, when we see the bases, there are different numbers, and we can write the two bases as power form of another base, that is 3. See, 9 can be written as 3 cube or 3 square. This means 3 square the whole power of 2x minus 4 is equal to, again, 27 can be written as power of base 3, that is 3 cube. Yes, 3 cube the power of 4x. Now this means to multiply 2x and negative 4, yes? So it becomes 3 the power of 2 times 2x, 4x minus 2 times negative 4 is, that is 8. So don't forget the number to multiply both numbers or both terms, and which is equivalent to 3 times 4 is 3 the power of 3 times 4 is 12. So this means 12x. So this means, this implies that the bases are now similar. We can simplify for exponents, that is 4x minus 8 is equal to 12x. Now 4x minus 12x is equal to 8. Now 4x minus 12x is negative 8x is equal to 8. Now dividing both sides by negative 8 by negative 8. Finally, x becomes what? Negative 1. You see, this is the value of x after we simplify. You can simplify this number by using what, or by substituting the value of negative 1. This is the first example. Okay, this is the first examples. Let me see the first examples. But that's related with power of exponents is, or solving equations involving exponents and radicals, or exponents and radicals. Now I'm not going to raise these exponents, these functions, because they are very important. Thus are C. Let me continue as D. D says what? The cube of 4 the power of 2x. 2x is equal to 4 the power of 3x minus 5. This is D. For E, 81 the power of 5x plus 2 is equal to 1 over 243. F says what? 3x plus 1 the power of 6 is equal to 64. Again, let me solve this only these 3 examples. Again, we will continue another examples. To solve this one, again we have to use this very important rules. Okay, we have to use this rules. This can be written as, okay, for the power of 2x and the whole power of 1 over 3. Since we can write as the power of rational exponents, right? So this means can be written as which is equivalent to 4 the power of 3x minus 5. This means we can write 4 the power of x times 1 over 3 is 2x over 3 is equal to 4 the power of 3x minus 5. We can use again the first rule. It says what the base are the same. So 2x over 3 is equal to 3x minus 5. Now we can solve this one. 2x over 3 minus 3x is equal to negative 5. Now this number is the first one is fraction, but the second one is normal number, make it over 1. So we have to multiply this number by 3. So 2x minus 9x. You see, when you multiply this number by 3, we will get what? 9x. Whole divided by what? 3 is equal to negative 5. Or you can multiply all the equations by what? 3 from grade 8 lessons. So 2x minus 9x is equal to negative 5 over 3, which is negative 2x minus 9x is negative 7x, right? Negative 7x over 3 is equal to negative 5. Now multiply both sides by what? Negative 3 over 7. Yes, negative 3 over 7. So 7 will cancel by 7. See, this is number 7. 3 by cancelled by 3. So we left what is x? X is equal to negative times negative is positive. So becomes what? 15 over 7. So the value of x must be what? Negative. Positive 15 over 7 in order to make this statement is true. This statement is true. So let you see C, big is B. Well, B it says what? E says 81 to the power of 5x plus 2. Yes, 5x plus 2 is equal to 1 over. This is plus 2. E says what? 81 the power of 5x plus 2 is equal to 1 over 243. This means can be written as 243 the power of negative 1, right? So we can write this number can be like this: 81 the power of 5x plus 2 is equal to 243 the power of negative 1. Since this is a fraction, okay, you can write as the inverse of the numbers. And 81 and 243 are different bases, and we have to change it to like bases. 81 means you can write as base of 3 or as base of 9, or let me write by base of 3. That is 81 means 3 to the power of 4. 3 to the power of 4 to the power of 5x plus 2 is equal to 243 means just multiply 81 by 3, you will get what? 243. That is 3 to the power of 5. Since the power of 4 is 81, we have to make it 3 to the power of 5. And the whole power of negative 1. Now 4 multiplies this number. Yes, 4 3 to the power of 4 times 5x is 20x. 4 times 2 is 8. Right? It's equal to 6 to the power of negative 5 times negative 1 is negative 5. Now the bases are the same. So this means now since the bases are the same, we can calculate the exponents. 20x plus 8 is equal to negative 5. This means 20x is equal to negative 5 minus 8. So 20x is equal to negative 5 minus negative 8 is negative 13, right? Negative 13. Dividing both sides by 20. So finally become x is equal to negative 13 over 20. This is the solution for what? This equation. This is the solution for this equation. You can substitute in this equation to solve or to whether it's equal or not. F says what? F 3x plus 1 the whole power of 6 is equal to 64. Again, this number cannot be, the base of these numbers are different. Again, we can write 64 as a base of 2, which is like this as power of 6. In this case, you see, we have to observe to solve this kind of numbers. We have to make this number as a base of what? 6, because with the number that we are going to find is in the base. See, previously we have seen the number, the value of x, or the value of the variable that we are going to find out are, or in the case of exponents. Now this is changing to what? The base. It becomes what? The lowercase, that's the base. So it becomes what? 3x plus 1 over the power of 6 is equal to the power of 6. We have to make it, okay? In this case, since the base, the needed value is in the base, we have to equalize what? The exponents, and we have to use the second rule. And the power of x is equal to the power of x. You see, exponents are the same, and the base are completely different numbers. If and only if the bases are the same. Therefore, since the exponents are the same, you see, exponents are the same, this means 3x plus 1 is equivalent to 2. Unless these two statements are not equal, the two expressions may not be equal. So to solve this one, 3x is equal to 2 minus 1. So 3x is equal to 2 minus 1 is 1. Dividing both sides by 3. So x is equal to 1 over 3. This is the value of x for f. Let me continue as G. It says again 3x plus 1 the whole square is equal to 4x minus 3 the power of 2. Again, similar with f, the bases are different and the exponents are the same, and the number we are going to find out is in the base. So the exponents are the same. This means 3x plus 1 is equal to 4x minus 3. Now 3x minus 4x is equal to negative 3 minus 1, right? Negative 3x minus 4x is negative x, right? Negative is equal to negative 4. Negative 3 minus negative 1 is negative 4. Now multiply both sides by or divide by negative 1. By negative 1. So this is x is equal to 4. The value of x must be what? Equal to 4. G H. Let me continue with brief examples. So it's 1 over, to make it visible, 1 over 16 the power of 3x minus 1 is equal to 32. Now this number is a fraction, not base, and this one is a normal number. So we have to write this number as power 4, okay? Power 4. In order to write this one, 16, you see the power of negative 1, right? And the whole power of 3x minus 2, and it is equivalent to 32. Since the number we are going to find out on the exponent, so we have to change the basis into like basis here. Yes, right. So 16 means you can write as 2 to the power of 4, and 32 can be written as 2 to the power of 5, right? So this means 2 to the power of negative 1 means negative 4, right? Negative 4, the whole power of 3x minus 2. Don't forget that the reason why I make 2 to the power of negative 4, 60 means 2 to the power of 4, and 4 times negative 1 is negative 4. That's the reason. It's equal to the power of 5. Now the bases are similar, and we have to multiply this one. To the power of negative 4 times 6 is negative 12x and plus 8. Negative 4 times negative 3 is positive. So it's equivalent to the power of 5. This means negative 12x plus 8 is equal to 5. Now I left it the solution for you because it is very simple. Negative 2x plus 8 is equal to 5. You can solve it, and finally the answer becomes what? Negative 1 over 4, right? Negative positive 1 over 4. You see, you can solve it by yourself. Okay, let us see another example. Another example which is related, very important to solve such kind of linear equations. Yes, such kind of linear equations. H, let's say I, in order to make it very simple here, 9 to the power of 2x plus 2 is equal to 1 over 81, the whole power of, this is multiplication times, 3 times x plus 2 is equal to 243, the power of negative 3x minus 2. This is exercise from your textbook, but let me solve it. Sometimes some students say it to be difficult, but it's very simple. We can change all the numbers as well, the same base, because the number we are going to find out is on the exponent part. On the exponent part. Therefore, let's write 9 as 3. Okay? 9 as the base of 3. 3 squared, the power of 2x plus 2 times, and 81 can be written as 81 the power of negative 1, that is 3 the power of negative 4. We can write this like this, the whole the power of x plus 2 is equal to, again 243 can be written as power form with base 3, 3 the power of 5, yes, 3 the power of 5, the whole power of negative 3x minus 2. Now, when you multiply, remember that a the power of x times a the power of y can be written as a the power of x plus y. Don't forget, when you doing multiplication of the numbers, we have to multiply exponents. So the bases are the same, and first let you multiply the either one. So it becomes what? 3 is the power of 2x times 3 is the power of 2 times 2x is 4x. 2 times 2 is plus equal 4 times 6 is the power of negative 4x. Negative 4 times x is negative 4 minus 8. Negative 4 times 2 is negative 8. Is equal to 3 is the power of 5 times negative 3 is negative 15x minus 10. It becomes what? 10. Now this is the case of multiplication, right? So 3 is the power of 4x plus 4 plus, because the bases are multiplications, right? Negative 4x minus 8 is equal to 3 is the power of negative 15x minus 10. Therefore, now the bases are the same, right? So it becomes 4x plus 4 minus 4x minus 8, you see, plus times minus is minus always, plus times minus is minus, is equal to negative 15x minus 10. Now 4x minus 4x is what? 0, right? This becomes what? 0. Negative 4 minus 8 is a negative 4 is equal to negative 15x minus 10. Now bring 10 to this the left side, because there is a similar number. Negative 4 plus 10 is equal to negative 15x. So negative 4 plus 10 is 6 is equal to negative 15x. Now dividing both sides by what? Negative 15 by negative 15. So this means it's cancelled, and 6 over negative 15 means by 3, 2 by 3, 5. So x is equal to negative 2 over 5 is the final answer for what? I. For the final answer for what? I. Now to remember that when you solve such kind of equations, first, in which part is it in the base or is it in the exponent? The later we are going to find out. After you change it, if the number is the number that we are going to find out in exponent case, you have to make the base are the same. Okay, the base are similar. But when you find out that when the number that you are going to find out the variable is in the base case, you have to make it the bases, the exponents are similar in order to make it work, in order to use these two rules. Okay, those two rules. Let me say another additional examples to make it very clear. Okay, to make it very clear. Let's say I, J, you can write J, it's coming I, or 16 the power of 3x plus 4 is equal to the power of 3x times 64 the power of 2x plus 1. Again, in this case, we are going to find out the value of the variable is existed in exponent part. So we have to make all the bases into what? Like bases, okay, like bases. So this number 60 can be written as a power of base or power of 2. So 2 the power of 4 is 60, you know that. The whole the power of 3x plus 4 is equal to the power of 3x times, again 64 can be written as a power of base of 2 with power to the power of 6, right? To the power of 6, the whole the power of 2x plus 1. Now the all the bases are similar, okay, similar. This means we can write therefore 4 times 3x plus 4, see, is equal to, you have to add, okay, this one, because the two bases are different. So 3x plus 6 times 2x plus 1, 2x plus 1. Now 4 times 6 is 12x plus 16, see, 4 times 6 is 16, is equal to 3x plus 6 times 2x is 12x, right? 12x. 6 times 1 is plus 6. Now this means 12x minus 3x minus 12x is equal to 6 minus 16. Bring it like volume, meaning collecting like terms. 12x minus 12x becomes what? 0, right? Negative 3x is equal to 6 minus 16 is negative 10, right? Negative 3. Now dividing both sides by negative 3. By negative 3. So this means x is equal to 10 over 3. The value of x must be what? 10 over 3 in order to equalize this expression. Another one, let's say k, for example k, or we can say that 9 the power of 2x times 27 the power of 1 minus x is equal to 81 the power of 2x plus 1. This is again exercise from your textbook, but let me do. Again, the number that we are going to find out is existed in exponent part. We have to make it. Their bases are similar. See, it's here again. Let me tell you, if the bases are the same, okay, the bases are the same, and the exponents are different. Okay, the exponents are different variables. If the two exponents are the same, meaning if the number that we are going to find out is existed in the exponent part, we have to change the basis into like. If the number or the value of the variable that we are going to find out is in a base case or in the base part, we have to equalize the two exponents. In this case, 9 to x, so the variable is in a exponent form. So we have to change all the bases into what? Like bases. So 9 can be written as 3 the power of 2, right? 3 the power of 2, the whole power of 2x times 27 also, 3 cube, the whole power of y minus x is equal to 81 again, 3 the power of 4, and the whole power of 2x plus 1. Now the bases are similar. Therefore, we can write, since the base, in this case, the bases are the same, 2 times 2x plus 3 times 1 minus x. Because already we make this base are similar, and when the bases are the same, we have to add the exponents, right? In the case of multiplication of powers, it's equal to 4 times 2x plus 1. We can do 2 times 2x is 4x plus 3 times 3 minus 3x. X is equal to 4 times 2x is 8x. 4 times 1 is 4. Now these are the same. 4x minus x is x, right? X plus 3 is equal to 8x plus 4. 8x plus 4. Now therefore x minus 8x is equal to 4 minus 3. Now rearranging like this. See? X plus 3 is equal to 8x plus 4 means bring 8x to the left and bring 3 to the right side. So x minus 8x is negative 7x. Is equal to 4 minus 3 is 1. Now dividing both sides by negative 7. Negative 7. So this means x is equal to negative 1 over 7. This is the value of x to solve what? These equations or the set kind of equations. In this case, to finalize, to solve equations of exponents and radicals, when the value of the variable you are going to find out existed in the exponent part, you have to make it the bases are similar. But when the value of or the number or the value or the x is existed in the base part, you have to change it, or you have to make it the exponents are like in order to solve the equations, unless it is impossible to find out the solutions. Thank you very much. Don't forget to share and subscribe for your friends and peers. Thank you.